Hi, I'm Dr. Brian Curtis, one of the paleontologists here at Fossil Crates, and today we're on location at the Arizona Museum of Natural History. And this animal in front of me is really cool. This one's Probactrosaurus gobiensis. This character was found in the Gobi Desert of Mongolia and is a very advanced iguanodon. Iguanodons are cool because, well, they gave rise to hadrosaurs, but also they're cool because they were the food of everything else. They don't have sharp, particularly no horns, no armor, no frills. They relied on speed. Now, the iguanodons, the big iguanodons, had big thumb spikes. So you could argue that you could jab and jab and jab away. But otherwise, they relied on being able to outrun animals. Kind of think of them as a deer of the Cretaceous. This particular iguanodon is a very advanced iguanodon. It definitely is very closely related to hadrosaurs. Hadrosaurs didn't live in water. When I grew up, they did. Everyone drew the duckbill dinosaurs, and I think they were thrown because this bill looks like a duck. It's wide. And it has no teeth at the front. It's called a predentary. And the teeth don't start till way back here. So you've got a bunch of room for it to go and grab plants and bring it in. Now, they did chew, not like mammals with our fancy jaws, but they do have these dental batteries, so they have lots and lots of little tiny teeth that are packed together side by side, so there's no gaps at all. You could not floss a hadrosaur, nor a ceratopsian. And they had them stacked 3, 4, 5 deep. It's like a series of stairs with teeth. And when it closed its mouth, it had these little cheeks on the side to keep the plants from spilling out, and then it would run its jaw back and forth and grind up the plants. So these animals with that duck bill were envisioned as living in the water. But the reality is when you look at the skeleton, the tail of these animals, the iguanodons and the hadrosaurs, though they have these tall spines, they're ossified. They have these ossifications in them that lock them together. They're not on display here. It's missing the chevron bones. But if it did, you would see the tail can't move laterally. If you swim, you want to be able to get some power. That tail couldn't move individually, the sinuous nature. It was one long, solid device. Also, when you look at its hands and its arms, it wasn't designed to paddle or to swim. Not at all. I mean, it could kick off the bottom if it needed to, and probably a little kick for a bit, but they're skeletons. There is no aquatic adaptations other than the fact that the front of its mouth looks like a duck. That's one of the cool things about paleontology is it's still a relatively young science and things are changing all the time. And the ideas from almost 200 or 150 years ago, we can test them with we keep layering our knowledge one after the other. And so everyone who wants to be a paleontologist, you're going to be able to go through and make all kinds of discoveries that we didn't think about. We didn't think about it because it just didn't occur to us, or we have our own biases, or you find really cool new material. So I really like this exhibit. Here's an example of that tail on the juvenile with the tall spines. So these tall spines would have been covered in flesh. You've heard of animals like Spinosaurus that have really tall spines and have a real sail. This just would have been probably covered in muscles and really allowed it to get some power. You can see it has these long legs in relation to the rest of the body, so it definitely could run. And its toes, when you look at the toes, they are almost like they're spades. They're these. I'll put one on the screen for you. Why don't I do that? So Probactrosaurus, pretty cool animal. I really like the small versus large.
This is the mom. We don't know if it's truly a female. Probactrosaurus. And you can see me back there pondering the world. This is the baby Probactrosaurus. And cute as a button, much smaller than the adult. You can see that it has the karate chop hands. As we go backwards, you'll see these wide splayed hands with that twisted radius ulna. And it's a generic build, long legs, longish arms, straight tail. But that baby is so cute. What you are seeing here is the cover page of the Rosdevsky, apologies if I pronounced it wrong, 1966 publication that describes Probactrosaurus gobiensis and another species, Probactrosaurus alashinaicus. And pro means before, and The reason he named it before is because if you're looking at this stack here, this is the one that was found on the oldest side. And then they found this one in the middle layer, and Bactrosaurus, which had been found by the American Museum expeditions and described by Gilmore, is the youngest of the bunch. And Rozdevsky wondered if maybe you might even have some evolutionary series here. He made these different species of each other, though this specimen here, the Aleshanicus specimen, is apparently lost. And so as a result, we don't really know for 100% sure. And they certainly look different from this top view. Bactrosaurus and Probactrosaurus gobiensis have a lot of similarities to me, whereas this other one does not. It looks different. Now, of Probactrosaurus gobiensis, they have, as you see here, a list of elements that they actually provide measurements for in the paper. He lists 3 incomplete skeletons plus articulated bits and pieces and lots of bone. And he noted variation was present, 5 to 10% between individuals of different proportions. However, of the second species, he simply listed, as you see here, skull, jaws, etc., of several specimens. But it is not clear to me what's left. He had this great quote in the paper. Some characters reach over from one taxon to the next, and that to draw systematic boundaries between them is to some extent a relative or arbitrary matter. And that is as true today as it was in 1966. Let's go through a video montage. That's me in the background with my cool Meta glasses. I was trying them out in the museum. And this is the mom, we'll call it the mom, and that's the baby. And these were made as part of the Great Russian Dinosaur Traveling Exhibit in the 1990s. And we ended up with them here at the museum. And so it's pretty cool to compare the adult versus juvenile. This is the adult skull. Notice there's no teeth in it. It makes me giggle. They apparently didn't want to sculpt them in. And it's difficult to know which of these elements were made from original bone and which ones are pure artistic sculpturing. I don't know. I can't tell you for certain. But I can tell you that this view looking up at the palate of the Probactrosaurus mom shows off that classic duckish-like bill. All of this bone up on top would have been covered in what we call a rhamphotheca, which would have looked like a duck's bill. And then there's a big gap called the diastema, and then there's teeth in the back. We'll take a look at that in a moment on the juvenile. But on the adult, again, that's my hand for scale. It was not toothless in life. It has a big nose, big eyes, and relied on speed to get away. Now you see here the juvenile. You can see, if you know what you're looking at, this is all skull. There doesn't appear to be a single real bone in this. And you see the beautiful teeth. Now this is actually what is called a hadrosauroid. This is a basal hadrosaur. When it was originally described, Rozdevsky wondered, he called it an iguanodont because it has a thumb spike, but he also struggled wondering, could this be along the lines of a hadrosaur? And he was spot on in that sense of wonderment. You can see again the proportions of the juveniles and adults, and you can see the tall spines that they recreated. These are restoration, but they're directionally correct. We know iguanodonts and hadrosaurs both have tall neural spines down the back as well as the tail. The recent mummy paper that came out in Halloweenish of 2025 talked about how there would have been a large fleshy sail across the top of these, and I suspect that this had it as well. When you see a tail that has tall neural spines, the top of the tail, and tall chevrons about the same height, you know you have a large caudofemoralis longus and brevis. Those are muscles that come off the back of the femur and run down the tail. Beautiful, beautiful long tail. And though it's a lot of resto, it's probably similar to what it would have looked like in life. Now, the Probactrosaurus exhibit we have here is really trying to make a point, which unfortunately we make wrong. And that is that these animals had changed their hand shape from juvenile to adult. The very first thing that you probably didn't notice is this blurry area up top shows the radius and ulna crossing like in a human being. Well, in reality, the radius and ulna don't cross on these dinosaurs. So the wrist is wrong, the forearm is wrong, which puts the wrist wrong. Here's the thumb spike, and then they drew it with these, or made it with these 2 hoof-like fingers at the distal tip. And we know that in hadrosaurs, these hands were actually tightly wrapped, and they were like flesh mittens, scale mittens wrapped around it. Now, I don't know how tightly wrapped the iguanodont or basal hadrosauroid hands were. It's probably some not as tight as advanced hadrosaurs, the late Cretaceous. We're talking the early Cretaceous here. But this thumb spike shows that it's got some iguanodonted characters in it still. It's really down in there in that transitional zone. Here it is looking at what I call the worm's eye view, looking up at the hand underneath. And the way they've got these bones crossed, they're attempting to show that the adult walked on its hands at time. It walked on its hands, but the radius and ulna were not crossed, and I suspect these were more tightly together. Our juvenile has arms where they are not crossed, the ulna and radius, and they look like they're ninjas doing karate chops. I love this view, by the way. It reminds me of like a Godzilla coming at you. Here's the hands with the cute little thumb spike. Notice these are not crossed. The radius and ulna are straight. And you have my arms for scale. Now, this exhibit was meant to show that juveniles were fully bipedal running around, and as they grew up, their arms changed in morphology. We don't believe that's the case today. This exhibit was made going up almost 50 years ago. And as a result, science has evolved, but changing out exhibits isn't as easy as you'd think. We'd have to remake the radius and ulna and reattach it. So instead, I choose to view it as a way of showing differences and talking about how science evolves and our knowledge evolves. I'm Dr. Brian Curtis with Fossil Crate saying thank you kindly. Adios.